and Assalamualaikum everyone. My name is Siti Nurlaila Nadira binti Muhammad Fakri from J4EE 1113B1. Today I'm going to do a presentation video on Electronics 1 Assignment 3. So, as you can see here, there are 6 steps to answer this question. The first step is construct the transfer curve table based on the formula given. The second step is draw the transfer curve on the graph paper. The third step is find KVL from the constructed circuit that consists VGS and ID. The fourth step is construct linear graph table based on KVL in step number 3. The fifth step is draw the linear graph on the same graph paper with the transfer curve. And the final step is find the intersection point between transfer curve and linear graph to determine IDQ and VGSQ. Circuit from the given question. First, we need to identify the type of the circuit. As we can see here, the arrow pointed into the FET, so it is N-channel. We know that this circuit is from the MOSFET family, but we need to identify either it is E MOSFET or D MOSFET. The type for E MOSFET is like this, and the type for D MOSFET is like this. So, the circuit, the FET here, show that it is type for D MOSFET. This circuit is N-channel D MOSFET type. The question asks to find the drain current IDQ, the DC gate source voltage VGSQ, the drain source voltage VDSQ, the terminal voltage VS and VD. And it also gives the formula to find the ID. The FET we can find either using graphical method or mathematical method, but Sir Zahari suggests to use graphical method as it is easy to use. During the DC analysis, the capacitor condition is in open circuit. This first capacitor, second capacitor is in open circuit, and this capacitor also. And we can simplify this circuit between these two resistors, R1 and R2, by using RTH and VTH. First, we need to find the transfer curve table. Find the transfer curve table by using the information given. IDSS equal to 6 milliampere, VP equal to negative 3 volt. Substitute into the formula, and we can find the transfer curve table. And the transfer curve table will be like this. The range for VGS we can find from the value of VP. The value of VP is equal to negative 3 volt. So the VGS range will be from 0 to negative 3 volt. Insert the value of VGS and the value of IDSS into the equation, and we can find the value of ID. So for VGS 0 volt, it is equal to 6 milliampere. VGS negative 1 volt, it is equal to 2.7 milliampere. VGS negative 2 volt, it is equal to 0.7 milliampere. VGS negative 3 volt, it is equal to 0 milliampere. And insert all the information in the table here into the graph paper. So for FET DC analysis, the graph paper is a very important thing. At the x-axis is VGS value, and at the y-axis is ID value. Plot all the information before, and we will get the transfer curve graph. We can use freehand, or to make it nice and tidy, we can use flexible ruler. the transfer curve will be like this. This is the transfer curve. Next, the third step is, after we simplify the circuit before, we will get the circuit like this. This is the value of RTH, 9.17 mega, and the value for VTH, 1.67 volt. The third step is find KVL from the constructed circuit that consists VGS and ID. We must perform the KVL at the loop which consists two parameters, which is VGS and ID. So as we can see at the circuit, the VGS is located here and the IS is located here. IS is equal to ID. So we can perform KVL from this ground to this ground at this loop. And the equation we will get like this. Negative 1.67 plus 9.17 mega Ig plus VGS plus 750 Is. So we must follow the current flow. Is is equal to ID, Ig is equal to 0 ampere, and we will get this equation. VGS is equal to 1.67 minus 750 ID. From this equation, we can find the linear graph table. The step 4 is to construct the linear graph table based on KVL in step number 3. From this equation, we can find the value for VGS. The range for ID, I use the range here from the graph before. From this range for ID. So, we will get 1.67 volt for 0 milliampere. For 2 milli, we will get 0.17. 4 milli, we will get negative 1.33 volt. For 6 milli, we will get negative 2.83 volt. The step number 5 is to draw the linear graph at the same graph paper before. So, we will get this linear graph after we plot all the information from this table. The step number 6 is to find the intersection between transfer curve and the linear graph to determine the value for IDQ and VGSQ. Between these two graphs, the transfer curve and the linear graph, we will get the intersection point. The vertical value is IDQ. So I'll get here 3.28 milliampere, and the horizontal value is the value for VGSQ, which is I'll get negative 0.8 volt. So from the graph, we write here the value for VGSQ and the value for IDQ. The question before asked to find the value of IDQ and VGSQ. So we must find the value of VDSQ and the value of terminal voltage Vs and Vd. We can find the value of VDSQ by using KVL at the certain loop. So from this circuit, we can find the value of VDSQ from this ground to this ground, but I make it simple. I used to find the VDSQ by using value of Vd minus with value of Vs, because VDSQ is equal to Vd minus Vs. So at the terminal voltage Vd at point Vd and at the terminal voltage Vs at point Vs. Perform the KVL from this ground to this ground for Vs and KVL at this ground to this ground for Vd. So from this KVL at this loop, we can make it simple by add the minus plus minus symbol at each component to make it easy to write the equation. So for VD, it is negative 20 volt plus 1.8 K ID plus VD, and we will get the value for VD is 14.096, and for VS, it is negative VS plus 750 IS, which is IS equal to ID, and we will get the value for VS is 2.46 volt. And for the drain source voltage, which is VDSQ, minus between these two values, VD and VS, and we will get the value for VDS is 11.636 volt.